I'm Elisabet Romero, group leader at ICIQ since 2018, and our group focuses on biophysics research. Our main research lines are natural and artificial photosynthesis, and our approach follows the sequence understand to design and construct in order to implement. So the idea here is to understand the photosynthetic process by which plants, algae and bacteria convert solar energy into another form of energy that we can use. At this point we have a quite detailed understanding of this process, so the idea here is to take this knowledge and put it into action to design and construct a series of bio-inspired chromophore-protein assemblies which will recreate the design principles of photosynthesis. In this way we could absorb sunlight and convert it into a separation of charges, which is what we need to convert solar energy to electricity or to fuel. In a second phase, the idea is to couple these charge separation units to catalysts in order to generate solar fuels, which are a form of energy that can be stored and transported. To investigate these systems, we use a series of tools, mainly spectroscopic tools. We use both steady-state and time-resolved ultrafast spectroscopic methods, in which we can understand with very good detail how the energy landscape of these systems is and how the dynamics of energy and electron transfer takes place in these systems. In addition, we are using also theoretical tools. These are molecular dynamic simulations which allow us to go beyond the experiment and predict how our chromophore-protein assemblies will behave. I would like to highlight that all these research activities are only possible with a combined effort of a talented and motivated group of researchers, PhD students and postdoctoral researchers, together with a network of collaborations. Overall, our group aims to create a new generation of bio-inspired solar energy conversion systems to provide a renewable, safe and an inexpensive energy solution towards a sustainable future.